Okay, so thanks for coming so early. Andrew and I thought we would be alone for this session, so we really appreciate you being here. Actually, I said Andrew and I, but we will be three, you'll see on stage. We have a special guest that is late, but he should arrive in 20 minutes or so. So yeah, today we'll talk about power of NSX, network virtualization for elastic apps and data center. And for that session, we have some lecture, but actually we want to spend as much time as possible on demo. And because we have a small audience here, instead of doing questions at the end, feel free to jump in, ask questions on the microphone, or I'll repeat the question for the recording, so we can make it interactive. Okay, so as I said, Andrew and I will be here for 1 hour to talk about all the power of NSX. For both of us, part of the NSBU business unit within VMware, because yes, VMware does not only compute, it does also network and security, as hopefully you know now. And the third guest will be our friend NSX Superdog. But he's a little bit not as early as you. I guess he had too much beer yesterday. But yeah, I'm sure he'll come here in a few minutes. So disclaimer, I'll skip that. It's the same you've seen for 3 days now. So let's jump directly into the content of the session. So set the scene. So NSX, who does not know NSX? Okay, so if I do the other way around, who knows NSX? Everybody, and everybody is still awake. Cool. So I'll go very fast on this. NSX, because you know it, is a software platform. Yes, VMware doesn't sell hardware. And it provides all the network and security services you need in an on-premise data center, but also in the cloud. I guess you've heard our big boss, or bosses, talking about those enhancements going live with NSX, or VMware NSX in Amazon. And so we do also offer network and security services in the cloud as well as on-premise. And we can do that natively, all the L2, L3, security, load balancing, VPN services, firewall services. We can do that natively, or they can be also extended with a rich ecosystem of partners with security guys like Checkpoint, Palo Alto Networks, Fortinet, guys from load balancers from F5, AV Networks, A10 Networks. So you have a rich choice, or you do everything natively because our internal products are also pretty cool. So that's all you know. I hope, because who has NSX? So you know NSX, but who has NSX? A small 30%, 40%. So for the other ones, I guess you played with NSX, hands-on lab or in your lab, and you noticed, I hope, because it's very important for us, that's the ease of use. We want to let you configure those services in a very friendly way. Because everything is done in software in one single place, so that helps you to create all those services in a very easy way. Amazing scale. I won't spend too much time on that. We have sessions on performance, but that's the power of distribution. Your router is not a physical router. Your router is not a VM. Your router is distributed on all the ESX. So the scale you have for routing, same for firewalling, is the scale of your ESX. If you need more power, you just add ESXs, hypervisors. And that's actually what the session will be focused on. NSX offers also great automation capabilities. Actually, everything you can do doing click all day long can be automated. You can even do more via API. The UI is always a little bit late, and so you can do more in API than doing the click. And this session will focus on that. Make sense? You're in the wrong room? You're in the right room? Cool. Now, automation doesn't require, NSX doesn't require automation. You can do click and still get great benefits. Who is using automation out of the people? A couple of guys only? Okay, so you use NSX for the 40% of you, And I hope you noticed those benefits. It's much faster. Instead of deploying applications in days or weeks, now you can do click, 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 100 clicks, and you have switch, routers, firewalls, load balancers, and so on and so forth. So in few minutes, you have your whole topology, which is much better than weeks. Still with no automation. You have greater, deeper security with all the micro-segmentation stuff. If you want more information on security, I'm here at the end, but we also have deep sessions here at VMworld. Also the management, that's something important for NSX. That's cool to deploy stuff fast and in a friendly way, but if you can't manage and know what's happening in your network, then that's pretty not usable in production. So we have also some pretty cool stuff there. And upgrade. When you have to upgrade a data center, if you make everything physical, you have to upgrade your switches, then your routers, then your checkpoints you love, or the Palo Alto network you love, then the load balancer you love, and whatever Cisco you love, or Juniper, and it will take weeks. Now, since it's all centralized, that makes also the maintenance, the upgrade, much, much simpler. The backup, much, much simpler. So why automation? It's to go even beyond that. So lots of customers like you stopped before. We just want to show you what you can do when you go one step ahead and use the automation benefits. So you can deploy stuff even faster, because now instead of doing 100 click and break your mouse, you can do one click and boom, your logical network, security, everything, fancy stuff you do on NSX will be there. It's even high availability because you cannot do mistakes. The wrong click or the wrong whatever, now it's in a template, your network and security. So you can deploy it once, twice, 100 times, 100 times, that will always do the same thing. So you know that template works great, it will always work great. And higher resiliency, you can do fancy stuff like we will show you in a few minutes. That will help your network and your application to be alive all the time and react to things that are not in the norm, and all that in an automated session. So that's what we're talking about. All good? Okay, so let's start with the cool stuff. We have 4 things we want to talk about, actually 3, because the first one is covered in 2 specific sessions. I'll start with this one. This one is to help you for the newbies, the guys who didn't do any automation and are new to scripting and all that stuff. So you have an introduction, and you have not a deep dive, but something that will go a little bit deeper with some cool guys from NSBU as well, to help you if you don't have any knowledge on automation, to help you to do the first steps. And it's using some VMware products, VRO and VRA, vRealize Orchestrator and vRealize Automation. Now I want to jump in the core of my session. So it was 8-minute introduction. Still awake? Cool. The first tool we want to present to you. Those tools are completely open sourced. You can use them, feel free, and they are completely available to anybody. We don't charge anything for that. So the first tool we want to show you is NSX LB Autoscale. Okay, I guess I'm not a marketing guy. It's not the most fancy name. But what is it? This tool I built. So the idea is to do something you may have heard for a few years, but pretty much nobody is doing because it's quite complex to do. It's to have a pool. So you have a load balancer. Oh, who knows load balancing? Everybody, cool. So the goal is you have a load balancer, and this load balancer will share the load among multiple servers, and this load balancer will detect if a server is down and remove it from the pool. So that's the load balancer we do. We can do fancy stuff like SSL offload, like URL load balancing. But something we do not do by default is to change the size of the pool based on events. And when everything goes well, you load balance your 3-tier app, typical 3-tier app, that will go to a couple of web servers front end, that will go to a couple of application servers, middle tier, all that load balanced, and will go to the database. But then if the load increases, then your front end will be overloaded, and you need something that will automatically increase the size of the pool when the load increases. You don't want to be there and do all that manually, because you don't want to check that manually all the time. You want a tool to help you to do that. So that's the tool I built. So how does it work? It will check the load on your pool, and when the load starts, the tool will automatically, I hope you like the animation. It took me more time to do this slide than the tool itself. So I really hope you enjoy it. Okay, so this tool will check the load on the servers, and if you're in the range which you accept, then nothing happened and it's all beautiful. But then when you have more load, so the tool will test the CPU and the memory, and when you cross a threshold, the tool will do a couple of actions. The tool will talk to vCenter, which has nothing to do with NSX actually. The tool will talk to vCenter and clone a VM and create this new VM and start that new VM. Then it will talk to NSX and add that VM, that new VM, automatically in the pool. Here we go. And now you have 3 servers load balanced. The load goes down. And you're cool again, you're in your green zone. And then it's 2 a.m., your service, your application is no more very active. It's not like in Las Vegas, people sleep at night. And now all your 3 servers are pretty unloaded. So when you go below a threshold, then what the tool will do is talk to NSX to remove that server from the pool. And I have an option in the tool that can just remove the server on the pool like this, or do a graceful server shutdown. Because maybe your application, when a client starts to talk to this 3rd server, it needs to terminate its action, and it can take time, and you want to remove that server when everything is finished on that server. So I have this option, which is a VMware NSX LB option we have, which is new in 6.3. I don't know if you've heard about it. So I use that option, which is cool. Customers asked for it for a while. It's there now. And then it will remove it from vCenter, because there is no need to load vCenter with a VM that is unused. Okay, so that's what is the tool. So let's look at the tool. Thank you. And I'll do a live demo in a few minutes. Keep your clap. And yeah, big balls, everything live. Okay, so yeah, this is the same thing I just said, no need. So where do you find this tool? This tool is fully open source. You can find it on the VMware GitHub. And that's the URL, and of course you won't remember. I don't expect you to remember that. So if you, what you can do is simply power NSX auto scale LB, whatever, any name. Google is so smart. And yeah, here we go. The first one is the good one. And that's my tool. So it's open source, and as everything is open source, you must publish the code, and the code is here. It's actually not complex at all. It's using Power CLI for the VMware addicts. I use this language. I could have used some other stuff like Python or whatever, but I wanted to use for this tool something the VMware addicts use a lot, and I understand Power CLI. Is some PowerShell, and Power CLI is what VMware admins use a lot and are used to that. So I'm using this language. Who knows Power CLI? half, a little bit, yeah, half. Okay, come back. It's the beauty of open source. You can provide feedback, and if there is another language, another kind of tool you'd love to us to work on to give you this, feel free. We can work on that definitely. But yeah, Power CLI. That's what VMware vCenter Addicts use, and that's nothing fancy. It's just this. Like here, it's to get the VM name, or here it's to get the CPU. Those are vCenter commands. This is to add pool member in NSX. So those are Power CLI commands. You don't have to understand that, actually. You don't have to look at that. The only thing we ask you is a bunch of variables, because of course your lab or your production, for the 30-40% of you in production, is not using those parameters, obviously. So we just ask you at the beginning of the script to enter your vCenter IP address, username, password, the VM template you want to use for the cloning, the VM names you have in your pool, so Web01, Web02 for me, the VM name you want to use in vCenter once you clone that VM, the number of pool members you want, and all that is editable. You start with 2 minimum, like in this example, and you accept up to 3. You don't want to go up to 20 VMs. And you have to tell on which load balancer, NSX LB load balancer, which VIP, which pool it is, and how much CPU max and min for the threshold. And if you want to use a drain mode. That's pretty much it. And let's look at that live. Up. I'll go like this on my lab, so I don't have to put the password. Here we go. So that's the vCenter you know and you love, I hope. So nothing fancy here. You can do this at your place. I have an application with a couple of, wow, Ronomo in San Francisco? No, there is no earthquake here. Okay. So my typical 3-tier app with a couple of web servers, a couple of app servers, my DB, whatever, and my beautiful NSX, you also love, I hope, where I have my load balancer, and I have my pool with 2 web servers currently, and they are all up and happy, okay, beautiful. And I have my VIP 2020, 2022. And if I go on my VIP 2020, 2022, I created a small test page. I am on server 11, as you can see here, and 12, 11, 12. I'm load balanced. Okay, nothing fancy. Don't need to clap yet. Okay, so then that's my script. The same one you have on the GitHub. So here we go. I didn't change anything. Wow, my laptop is sometime lives burned. Yeah, wow, super slow. No, don't tell me. I'm just opening a file. Demo didn't start yet. Okay. Anyway, trust me, that's my script. Let's launch this when nothing is here. So I'm using Power CLI. And, oops, it's not this file, NSX, autoscale. It's not this one. Oops. There we go. I'll get there. Yeah. Yeah, use the mic, so it gives me time to, hey, that's my file.
Hi, I'm Ujjal from VMware.
Okay.
Great script, congratulations. I just wanted to find out how you check the CPU utilization as you load balance.
Yeah, so finally the file opened. So I'm using vCenter Power CLI commands for that. And where do I have this? It's somewhere in my script. Here we go. So get statistics, blah, blah, blah. And I check the CPU, I check the memory. I changed it. I changed this to be faster in my lab. Mm-hmm. But if you look at on the GitHub, I take the average of the last 5 minutes from what I remember. Where here I want that to be quick, so I just take the last information from vCenter, because I don't want to wait for 5 minutes to do the thing.
Okay.
That's the only tiny thing I changed.
Okay, fair.
Okay.
Thanks.
I guess I'm a little bit marketing here. Okay, so I'm showing it to you manually. I mean, I launch the script manually. What's going on? Why I cannot? Here we go. Man, this Windows is dying in front of you. Sorry for that. So you can see it's testing my 2 web servers. Web 1, Web 2, the CPU is nothing because there is pretty much no load. Of course, you don't want to do that all day long. Start the script, start the script, start the script. So you have to put that in a loop every minute. So you can do that in Linux if you want to do that in Windows. And I use Windows in front of you because I understand the VMware guys like Windows. You'll use task scheduler. And what you'll do is properties. You'll run that script every minute, and it will run every minute in the background. And I'm just doing it manually because I want to show you things. Why this laptop, this RDP is so slow? Oh, shoot. Oh, come on. I'm running, okay. So nothing happened as expected. Now, what I'll do is I'm connected on web server 1, and I'll do a loop, an infinite loop, to get the CPU up, because I want to quickly show you what happens when the server turns hot. And you can see the CPU is now at 100%, and the script runs every minute in a loop, but I'll do it now manually. And it's getting up. It's already at 22% because it takes the script, check the CPU for the last 20 seconds. So every 20 seconds, I mean. And here we go. It's at 99%, as you can see. And now a couple of actions happen. So it's creating a new VM. So you can see that here, but you can also see that directly in vCenter. Here we go. And that laptop is super slow. What's going on? Sorry for that. I'm refreshing. Yeah, sometimes recorded videos are nice. Here we go. The web VM, the new web VM is here, web clone 1. You can see that in the recent task. It cloned the VM, it powered on the VM. You have the output on that when I launch it manually, or the script logs everything in a log file as well. So you can keep this with the time. And then it's waiting for the VM to get its IP address. So how does that script work? It will get it from vCenter as well. Actually, nothing with NSX related to NSX so far. So the VM is booting. Here we go. It will get, it got the IP address from VMware. You see it's here. So the script should be smart enough and get it. Here we go, it got it. And now it's adding it to the pool. So if I check NSX, sting, sting, quick. Yeah, it goes slower than usual. Sorry for that. Because we have a second, or many other demos actually, I want you to see. And now I didn't do any click, I didn't lie, it's all live. And now, boom, I have my third VM. And if I check, I'm load balanced between 11, 12, and 13. You see it here. 11, 12, 13. So now I have 3 servers. Woohoo! You can clap now. Yeah. And thank you. I was not expecting that. Wow. Okay, then I stop my infinite loop. The CPU is getting down again. And I should have my script that runs every minute. But for this to do it live, and more interactive, I do it manually. So the CPU is still for vCenter at 90%. Let's wait a little bit. Here we go. The CPU is at 0%. So it's doing a couple of actions. It's moving the VM in drain mode, because I don't want to remove it immediately in case some people are still working on this third VM. So here we go. If we go to, I don't know what happens in Vegas. So you see, sorry for that. You see this third VM is in drain mode, so no new clients will be using it for a minute, but old clients using that one will still use that one, and it will last for a minute. Come on. And 1 minute later, what will happen is it will really remove completely the third VM from the pool and will delete the VM. And all that, again, can be done without going to the pool. Okay? You don't have to work, and your boss will believe you work. Okay? Here we go. It's doing this, and if we check quickly, I refresh. I have only 2 VMs now, and vCenter doesn't have the third VM here. Here we go. So that ends up my my demo. If you want more information on the script I'm using, how to build that, we have 2 great sessions. Both of them are done by Australians, so it's always fun to watch, even if you don't care about automation. And that's focusing on PowerCLI, PowerNSX, which is the language I'm using for this tool. And one was done last year. There is another one this year. They show you also some amazing stuff you can do with this tool. It's other examples. We're just building plenty of examples. And if you have ideas, feel free to bring them. We'll be happy to give you those open source. Or even better, if you build them, we can publish them on this VMware GitHub, and everybody will enjoy that. If you want more information on load balancing, pure load balancing, there is also a session. Nothing to do with automation, but everything they explain there can be automated as well. Okay, thanks for your time. One quick question, and then we'll show you a great second demo as well.
You've shown us, I'm assuming, NSXV, right?
So we are showing NSXV in this with those tools. NSXV, for those, it's the NSX for vSphere. We have 2 editions now. One which is NSXV, which is NSXT. Why 2 editions? Because we want to be sure NSX provide the best network and security services for everybody. Even those guys, you may not know, but some people don't use VMware, vCenter. So for those people who don't use VMware vCenter, we have an edition where NSX will give you also amazing network and security services, and it's called NSXT. You may have heard about it. I've done also some sessions on NSXT, but yeah, long story short, I'm showing it here, as you can see in this live demo, NSX for vSphere. Happy to do automation tools and great open source tools also for the other one, because the other edition can be fully automated as well. Okay, much longer than I expected. Andrew now, you can clap.
Thank you very much. Thank you. Good morning, everyone. Very delighted to be here to present the second half of this presentation. So I guess what Dimitri has been showing us is how to build expansion and contraction in your applications and have network virtualization as an architecture being very close to that to be able to be auto-scaled and be contracted at the same time. So really how to manage the life cycle of the application, thinking of it from also the network view. So what we're going to cover for the next 30 minutes actually is on the same area, but dealing with more of the failures scenarios across distributed data centers when we're thinking about distributed applications. So let's have a discussion about this. So what is site availability? So really, when we think about these big topics, this topic's about how to deal with distributed applications on disparate data centers that's geographically dispersed, and how to be able to manage failures in the event of a disaster. That's really the main crux of this talk. And as network engineers, we have to build resiliency, we build best practices to avoid these type of situations, but not often that we can get away with it. So when we're dealing with combination of failure scenarios, we can deal with different permutations, combinations. For example, everything can be seen as a network symptom. So for example, we're dealing with situations where an application residing on a compute host could lose power. You've got situations where you've got storage replication where that could fail, which also indicates that it's also a network symptom. We've got content switching scenarios where that can cause failures. So you can have many different types of points of failures that can actually cause these type of outages. And this is the area that we're going to spend a little bit of time in. So when we start to look at how to look at these things, you look at different technology options, different methods, different techniques. So you've got areas in networking where you can focus on how to solve it with routing protocols, how to solve it with other high-level constructs to achieve the same goal. Now, when you're looking at these different methods and different technology trends, you've got to start looking at what's the disaster and then what is the recovery point. And basically, based on what you pick, you'll determine what's the trade-off of doing that. So when dealing with any of distributed data center situations, in distributed application situations, we have to focus on a couple of things that are requirements before you can even get there. And obviously, you've got to focus on being able to have a tool chain that can support cloning of applications, mirroring of applications across different data centers. Also, storage is a very big requirement. Optical, fiber channel over IP, how to deal with data replication, synchronous, asynchronous-based techniques in storage. Based on which one you want to pick will determine how much data you're willing to lose, and based on that, you'll pick the right option for you guys. So, what we'll talk about really is DR, site recovery, and obviously that's a full stack discussion which we can't do in 30 minutes. But what we'll talk about is some areas of my interest that I've been playing in, and particularly I'll show you some examples here. So really the goal of our presentation for the rest of it is you've got data center 1 being active and you've got a hot standby on data center 2. So in the event this application is unreachable for whichever reason in the stack, we want to move it to a secondary data center. Okay, so we look at a number of different options. So I'll give you a few evaluations of what we can do, and particularly with what we can do with NSX. So we've got, in the event here, network type situations where you can use routing protocols. And you can use examples such as route health injection, Anycast, using BGP for manipulation of AS path, prepend, weights, all those attributes that have been known to us for a very long time to be able to achieve these such situations. If we start to look at building resiliency in a primary site, obviously we try to use things like IPSLA and make sure that we can keep traffic and keep the availability on the active site. So these models is really, as a network way of solving the problem, you want to avoid the site transition or the site switchover when you can. So these are the techniques you would use. Now, with what we do with NSX, you can consider a situation here where you've got a DNS record, store.example.com equals IP1, meaning that that's this prefix. All client requests will go to DC1. Now, how you would solve this with this situation, you would have a routing protocol metric where you'd be advertising /24 with a cost and metrics that are quite low, and then your standby site would be a metrics and cost that are much higher. So, and these are the things that you can do inside NSX. So as client requests come in, and anything fails, you can actually move between data centers. And like I mentioned, BGP with AS path, prepend, weights you can do. And with NSX, you have a number of different options too. You've got ways you can create a workflow in a runbook to say that in the event availability is down, let's run this set of instructions, just like we've seen what Dimitri did with Power NSX, and be able to do it in data center 2. So there are a number of ways you can do it, and these ways you can do it if you want to put the ownership and responsibility on network protocols and not another type of solution. So that's one way of solving it. Now, the other way of solving it is actually looking at a DNS-based solution. Now, this is things like F5 that build GTM type technology, and that's a global traffic management system, which basically has an extension to DNS that you can rewrite and switch records in the event of a disaster and so forth. Now, with these type of failure conditions, what we look for is building an architecture that's not really putting the ownership on the network, meaning that it's an architecture that's protocol independent because you're doing all the smarts at the DNS level. Now, giving you an example here again, so store.example.com equals IP1, and IP1 is got a virtual load balancer tied to app1, and IP2 is tied to load balancer IP2. So, going through this particular model, we go, well, in the event that clients are sending requests to data center 1, we will have an outage type situation, and we want to rewrite the records to point to IP2. Now, in the back end, there's a number of different smart techniques that are happening. You're looking at the session layer at layer 5 and at HTTP layer. If it's a 200 OK, do nothing. If it's something else, we want to do some retry and then switch the records. And this is an area that we've been seeing a lot of our customers ask us for a number of requirements to solve them at the DNS level. Now, that's an area that's been my personal interest for the last 5-6 months, working with a number of customers, purely working with the DR space. They would love to see more of these solutions solved at the DNS level as another alternative. So this is where I took my time over the last 5-6 months, and I wrote my own DNS server from scratch, as you do. And basically, it's not very complicated. You're dealing with the binary protocol, decoding the header fields, and building some extra logic to get some contextual information about NSX. So this is something that I've been personally working on, and I'm going to continue to iterate it over time, and I'll give you more information in a few slides. So, introducing Project Remora. This is my tool, my application that I've been developing over the last several months. And it is my version of solving the DR problem for site availability. And what we're looking at doing here is I've developed it as an authoritative control server that will have contextual knowledge of NSX, understand the knowledge through the data model of NSX. So I can choose to know about the load balancer health, the pool health that Dimitri showed you, and based on what I'm seeing here, I can determine what's a full failure, a partial failure, and whatnot. So just to be very, very clear, there are well-known authoritative control servers out there in the market. So you've got Bion version 5, you've got Infoblox, OpenDNS, Windows. This is responsible for your root domain, so your VMware.com, your top-level domain for your company. So I have no interest in getting anywhere near that, because that's responsible purely for a full-functioning DNS server. What I am interested in is to be able to delegate some of the most interesting records that we want to manipulate and we want to control based on the event of outages. For example, your front store website that is front to the customers where client requests come in. We want to be able to own that domain and be able to then manipulate it based on what NSX and the contextual information I'm getting from NSX. So to give you these examples here, how I've gone about designing this is if you look at a domain, one domain can have many records. Each record, you've got many types. You've got CNAME, A record, that are the two main ones that we want to work on. And in the architecture that I developed, I looked at developing a key value of record keys, meaning your fully qualified domain name, and then assigning it the successor IP address that's bound to that record. Now, in the event that there is a failure, what I'm looking at doing is then I'm taking my feasible successor IP address from my database, rewriting the records, and then switching it over when the time is right. Now, when the time is right actually depends, because in load balancer logic, you're going to have different states. You've got 200, 204, 404, 503, different error codes meaning different things. So based on these error codes and based on this logic, I wanted to ensure that we can retry and make sure that we can still stay on the primary site if possible. But if we know it's a no-go zone and it's dead, we move it across to the next data center. And that's the motivation of storing this. So this is the model. It's actually been submitted as a VMware Fling. So VMware Fling is an open source area where us as VMware engineers publish our tools and applications that's freely available for you guys. So I call it just life hacks. Anything that will make your life easier to do your operations and manage your infrastructure, it'll be there. So you'll find it on the portal, so VMware Flings. If you look it up in Google and type in NSX GSLB, you'll find this on the oncoming months. Okay, so there's two big things I'm going to focus on. Number one is how do you deal with partial failure based on what the APIs are telling me inside the network virtualization layer. Number two, how do I deal with full site failure? So let's start talking about the architecture of NSX that we can actually start looking at. Now, just to give you a quick high-level view, I've got a 3-tier architecture here. So you've got your web front end, your app logic, and your database layer. And I've got these constructs called universal logical switching that actually spans layer 2 across distributed data centers over layer 3. So you can have that logical network stretched. And what we've done, we've also created a universal distributed router, which is your default gateway for your VMs, that's also distributed across disparate platforms and distributed data centers. So that's what solves the east-west part. Then you've got the green boxes on the top that you're doing your virtual to physical inflection point, where you're doing routing protocols to the WAN border router, so OSPF BGP for all the north-south traffic. Now, you don't need, just to make very clear, you don't need to have an architecture like this. This is the latest and greatest out of our NSX feature set to support multi-site, but it does not need to look like this. This is just a best practice example. You could have local logical network, local logical networking, distributed routing. You may not even have a 3-tier app. You may even have one app, a monolith that represents your application. So you can still work it in that particular way. So what we will look at...
Just wanted to ask, because you're in Australia and everything is reversed, then east is on the left and west is on the left?
Then it's a difference, yeah.
Okay. So it doesn't work only in Australia when you're on the side of the atmosphere? Oh.
You have to look at that through a mirror first, then everything looks right for us. All right. So let's go through a particular example here. Here's the load balancer on the bottom. So as the traffic is coming in, we do the GSLB lookup, making sure that we're mapping the store to an address. We'll get to the load balancer in NSX. It will pick one way, round robin, least connection persistence, and all these type of things it'll pick. And based on that, oh, hang on, SuperDog's back again. It's taking the packet. Oh, geez, the VM's trying to get it. Oh, sorry guys, 1 second. All right, we're good, it's gone. Good work, VM. Has to put everything back. He always breaks stuff, that guy. All right. We're good. All right, let me show you again, guys. So here is the local load balancer going between two sites, and we're accessing the application A, and that's how it works. Now, events do happen. So disasters happen, whether it's a tornado, whether it's rain. Oh, gee, I think we're going to have weather forecast predicts the data center on the left is got some heavy rain. And they're buoyant VMs. All right, so as that's happening, all right, so we know that we're going to change the records based on the DNS level, and we're going to reroute the traffic to the other side. I'm glad they can swim. I'm glad they're safe. And away we go. Back the other way.
So that's a floating IP?
Yeah, it's floating IP. So that's what we're looking at dealing at full failures. And this is the things I'm going to show in my demonstration at the end of the session. All right. Now dealing with partial failures. Partial failures is something that is very big in our space as well. Now, when you're looking at partial failure, I have got a number of different ways I can solve that problem. Now, if you're having a VM that's gone down, I would look at picking a declarative scheduling model at the management layer that can make sure that you've got 3 workers working at all times to build your model. But if you don't have that, you do have other options to do at this layer as well to solve the partial problem. Now, what I mean by that is, let's consider this VM is sick. You can see the thermometer's going up. This guy's really out of it. From the GSLB level, it will know that it will have to reroute the traffic based on the API from NSX. Now, what we'll do here is, well, we know we're not going to go on the left-hand side. We're going to do the query lookup, and you can see at the top there that it's changed the record, and we're going to go down to this particular site. And this is coming from understanding the data model inside NSX. So really the motivation that I had with building DNS is building a custom backend that we can do modeling of virtual networking. So I can provide this indirect actuation into the network. Oh, hang on, SuperDog's back again, drinking beer and fixing the VM. He's a good guy, that guy, isn't he? And he's broken the screen. And now he's digging a hole. All right, hold on a second, guys. Oh, geez. All right, we're in a bit of trouble here. He's broken our screen. All right, thanks, guys. Good work, VMs. All right. Okay, so what we're going to do now, we're going to show a demonstration of what I described in those 2 examples actually on a live demo. Dimitri always wants me always to do a live demo, so we'll have to do this one. Number 5. Okay. All right. So be mindful, guys. I'm actually accessing a lab in Australia, so this may be a little bit slow, but we will we'll get there.
That's right. There's no Game of Thrones on tonight.
All right. I'm going to log into everything. Okay. Okay. Making sure this is up. All right. Right. Okay, DC1's up. DC2 is almost up. Very good. Okay, now let's go through this. So DC1, very straightforward. Three-tier application, like I mentioned, requirements. We've got to clone and mirror between all distributed data centers. So I've got my three-tier app over here. I've got my NSX constructs, like I described. We're going to focus on the load balancer, just like Dimitri showed you. So we'll go over here, and we'll go to the edge. So in the edge, we have one particular edge, edge 3. That's going to represent that green function I showed you in that picture. And we'll go to the load balancer. And in the load balancer pool, we will determine the statistics, what's up, what's not up. So just because a pool is up, that means that you can reach the VIP. But what I'm more interested in is every member, every worker is up down here. That's what I'm really interested in. So you can see here in this situation, it all is up. We have the virtual servers that are running here. And the virtual server is the VIP that gives us as users an illusion to the network that you're only accessing one IP address. And I just scroll down, and you can see here 192.168.0.20. And just to make sure we can access it, I'll hit this button, and hey, here you have it. I can actually refresh this app, and you'll see those green boxes actually change around here to determine that the load balancing actually took place. Now for DC2, just to show you guys, just to make sure everyone's on the same page, DC2 actually has the same thing. You've got a three-tier app described here. We have a load balancer in the NSX constructs for DC2, and here's the edge. And come up slowly. Here it is, edge number 5. And if you look at the load balancing constructs, it shows the statistics. We know that everything's up and running, up, 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 up. We're all okay. Great. Now we look at the virtual server, just to show you guys where all these IP addresses are all coming from. This VIP, this virtual IP, is represented by a different number. It's 192.168.1.21. So I'll show you here, 1.21 is accessible here. All fantastic, everything works. Now, the system that I wrote is Project Remora. So I didn't even give you guys the name. The Remora is actually a very lazy fish in the deep sea that actually has a suction cap on its head, and it actually sticks itself on every big fish as a host, and then the big fish will swim off to different places. And in the event that the big fish stops, it'll take off the suction cap and then attach it to another host, and away it goes. So just like Project Remora, the GSLB does very similar things. It connects itself to a load balancer. When load balancer dies, we connect to another one. So that's the big thing. So I've built it all in Ubuntu. So it's an application with a front end, with a MySQL back database, and running as a DNS and a network modeler. So what it'll ask you in the beginning of Project Remora is to enter the credentials of NSX Manager. So you can see here, I'm going to create some metadata about NSX and say that it's DC1 and give it the IP address of NSX for DC1, which is 0.7. Give it the username here, and then we're going to give it a password. And save. Oh, oops. One important thing to do when you start things. Start the app. All right, we're good. And resend. Okay, start again. All right. Okay, all right. So we'll set up the NSX DC1, the IP address, and make sure I plug this right. All right, DC1's plugged in here. We're going to do NSX DC2. We're going to put the IP address in, 0.8. Oh, no, I made a mistake there. Sorry, guys. Passwords are always funny. All right. Oh, name, yes, of course. And save. Oh, thanks, guys. It's easy where you are. Okay, great. All right, now we're going to go down to the zone information. Obviously, example.com is what we're very interested in. And what we're going to look at is building records for this thing called store.example.com, which has been populated here. All right, so if I add my record data, it'll give you some options. Here you've got store.example.com, and we're going to give it the IP address of data center 1, 0.20, give it the edge ID of edge ID 3, if you remember, edge ID 3, a record, give it a TTL of number 5, and then look at making it a primary. So that's going to be the primary record for store.example.com. So we'll save that. Now, if you go down to the bottom of this portal, you'll actually see that there's a little green dash here that indicates it is the primary record for that store.example.com. Now we're going to build a secondary IP address for 1.21, and we're going to give it an edge ID 5, which is the secondary DC, and we're going to drop down this box here and give it DC2, give it an A record, and make sure it's aggressive with a TTL of number 5. Make sure that the primary is no, because we're going to do an active standby. Now that we've got that all together, here we go, all done. So, all working well. I'm just going to show you the load balancer health just to give you a debug of what this application looks like when it starts. So it tells you it's authoritative server for example.com. And we'll start to see that the VIP is healthy with 0.20. So it knows that everything is all good. Now, what we want to do is, let's start using this domain. So if I want to go to store.example.com, we should hit it, as you can see here. Great, it works. And you can see here, if I do a ping on store.example.com, you'll see that 192.168.0.20, exactly what I said in my DNS server. Now let's emulate a failure. This is where the fun begins. So what I'll do is I'll find the uplink in the NSX edge, and I'm just going to just tear it down by disconnecting the uplink interface. This is going to be fun. All right, it's off, down. Now that it's down, what we will do is go back to the project Remora. Now, it does a poll every 6 seconds or so, just to see, are you coming back with a 200 OK message? Obviously, it depends on where the actual issue will rely on. It may take up to 10 seconds for the load balancer to determine there's a failure on this particular site. So far, everything seems to be working okay. Right now, we have to do a bit of a wait and relax a little bit. I hate being in this situation. And we'll wait for the HTTP timeout is what we're expecting to find on this one.
Using
I'm using a MySQL MariaDB backend, and I have bind functionality that I'm going to support as well. Yeah. So we're still waiting. There we go. So HTTP has timed out. You can see here, we have to reroute to the next available VIP. There we have it. We now moved on to 1.21 is now healthy. So if I go back to here and refresh this page, everything will still work. Fantastic. Now just to prove that the records have changed, I'll just do another ping again, and you'll see 0.20 up here is now 1.21. We've actually rerouted it based on a full site failure. So that's example number 1. So what do you think about that so far? Cool. Now the tricky one is the next one. So I'll bring this guy back up. So I'm going to put this back in rotation. So in my code, I take load balancers in and out of rotation in the event there's a failure. So we don't want to load balance to these guys if there's something wrong with them. Now let's go back to this situation. Let's go now to the secondary data center where all clients are requesting to this particular data center. So let me show you now what this actually does look like. We're gonna emulate something a bit more interesting. So let's say that Web 01 might have been kicked off the network. Maybe there was a particular issue that's happened. Maybe network, not network related. Someone's kicked the power out. In this instance, I'm just going to disconnect the NIC off this VM and take it offline. Now, based on this partial failure, now we want to know is, in the event that a VM is degraded, what do you want to do? Now, in my code, I'm going to say, let's rewrite the records to the primary site again. That's what we're going to do. So see what you can see here? Here you have it. The load balancer is being degraded. We are now it's timed out, and we now have gone back to 0.20 because I've put that back into the code. Fantastic. So if I go back to store.com, make sure everything's working, which it is, and give you guys another ping just to show it. Now you can see it. We've gone back to 20. So this is the model. This is the project that I've been very passionate about, very motivated about to improve incrementally. This is something that I'm going to do more of because there's a lot more rich data that we can get from NSX. I'm interested in finding out the propagation delay, processing delay, transmission delay, queuing delay, start building more network metrics that we can use, and then start feeding it into this application to make better intelligent decisions on a DNS-based approach for distributed data centers. So that's my main goal. And you'll get this on a VMware Fling in the oncoming months. So number 1 to the PowerPoint?
Number 3.
3? Okay. All right, so we're now back to the PowerPoint. And
yeah, it's because it's black.
Black. Okay, demo is finished. Okay, we've now come to the end of our presentation. We've showed you 2 types of load balancing use cases for autoscale and dealing with partial failure and full site failure for distributed data centers. We do appreciate you guys coming very early to come and attend our session. It actually means a lot to us. We weren't hoping it would be by ourselves, so we really appreciate it. And we'll open up for Q&A.
We did Q&A during the thing. If you have other questions, yeah, feel free to stop by at the end. We'll stay for 15 minutes. Don't forget the survey. Oh, there is a question. Yeah.
Yep.
Don't forget the survey. We appreciate that. I hope we wanted to make it interactive and fun. I hope you appreciated the time also we spent on the deck, not only on the tools you'll have to use. You are free to use. And we appreciate feedback. So go there. There are a lot of open source tools, open source, free, from VMware. Yes, those 2 words exist. And feel free to use them and give feedback. Thank you. And one question before we close and we're kicked out.
Sure. Well, thank you very much this morning, gents. It was a great presentation, and congrats to both of you on bringing some great new features to NSX. I guess a question for you, Babs. So looking at the way the global load balancing works, I mean, one of the challenges also is then looking at the uplink failures or the ingress, so the firewall, the internet connection. So one of the things that F5 GTMs do is they do a cross-site iQuery across the internet, and that way they have state knowledge of the connection. I mean, obviously at this stage, you know, you're able to pull things from NSX around, is the app up, is the load balancer up? Is that something you're looking at to be able to actually understand the...
Yeah, that's a great question. So in terms of active-active, we need to have some sort of groups to make sure if any asymmetric flows happen, obviously the firewall will take effect, which is why we're doing symmetric flows for now, and then we'll start to look at what we can do in the active-active at a future state. But I do want to get there at a longer term. That's the goal.
But the piece, just to add up some information on this, so for this to work, you want the whole traffic to still go to DC1 because DC1 is not dead in your use case. It's the application in DC1 which is dead. In that case, so you want still to go to DC1, go to a VPN tunnel and go to DC2. Something pretty cool, this can be done today. It can be added with automation, so you don't have to touch anything. So we'll have to enhance the automation tool, but this can be done today and with only NSX in the picture. Because VPN, IPsec, is also a service that is available natively in NSX. So we can do that with only NSX. Now, if you love another IPsec vendor because you have it and you love it and you don't want to use me, fine. NSX is a platform. You don't have to use all the network and services from NSX. We have an ecosystem and partners and all that great. But if you don't want to give money to somebody else to do the IPsec VPN, we can do that for you. And actually that service, once you buy NSX, you still give us money. Once you buy NSX, you have this extra service also included.
Cool. Thanks, Josh.
Thanks, guys.
Thanks, everyone. Enjoy the rest of the VMworld. Have a good one.